The next thing is the document object model. So what we've seen so far is HTML with CSS, so that's basically how it looks like, but not what it does. So I explained that what it does, or what an application does on the client side, is specified in a programming language, to which we come in a while. And this programming language obviously has to talk to the page it runs in. So the programming interface of the programming language to the page it runs in is called the DOM, the document object model. So the document object model is basically an API for structured text. And to that API, I come in a while. But for here, or for now, only so much. Basically, this document object model is something like the operating system API for classical applications. So it is a very fundamental thing, and you expect it to be very consistent and very well thought out and very stable and all that, which it actually turns out not to be. The next technology is JavaScript. So that's the programming language. And this programming language has been widely ridiculed for certain of its properties, particularly for its name. And also it has the bad reputation of being a silly language and not really respectable and all that, which it turns out it isn't. So it is actually a real nice language that has real nice properties and has nothing to do, which is one of its nice properties, with Java, actually. But anyway. And by the way, tomorrow I'm going to talk about a little bit more about this JavaScript programming language. So for now, just to mention, it is a real programming language in which you can write real nice programs. So the next big thing that goes into Ajax-based web applications is, of course, HTTP. And in particular, you have to have a programming interface to HTTP as well. So if you want to do from your JavaScript application, or from your JavaScript application logic, if you want to talk to the server, then you have to have an interface to it. So this interface is called, or nowadays is called XML HTTP request. So if you wonder about the capitalization of this name, why these are all capitals, why these are not capitals, then you hit it right on the spot. Actually, this is all also not really very well thought out. So basically what you need is an API to HTTP, and what you transfer over HTTP should not be so closely connected with the fact that you are transferring something at all. However, this object that is available in most modern browsers like Firefox and Safari and so on, basically rolls this task of making an HTTP session or making an HTTP request and transferring and decoding an XML formatted response into one object, although it doesn't have to do too much with each other. And I'm coming back to that in a while anyway. And the last ingredient is the transfer data format that you use to transfer those data that you that you use to marshal those data that you transfer over HTTP. So, and as I said, that is commonly regarded to necessarily be XML, although there are alternatives, and one of these alternatives are JavaScript object literals that are nowadays known as JavaScript object notation, so which is basically only JavaScript object literals. Anyway, so just a brief illustration of the DOM, the document object model. And by the way, or just one mention, if I talk about DOM or the DOM, then it is usually the document object model for HTTP as defined by the World Wide Web Consortium. So, and it has to somehow be distinguished from the concept of the DOM, that is to have an API for a document format. So, and many other document formats besides XML and HTML also have APIs, which make those APIs which make those APIs DOMs if this API happens to be object structured or object oriented. And other document formats which have document object models are, for instance, PDF and Shockwave, I'm sure, though I guess, but I'm not sure. And VRML, for instance, was another document format back then that also had a document object model effectively. Anyway, so this is a brief excerpt from one interface definition that is part of the document object model specification. so much only. The document object model of an HTML page looks like a tree. So that's basically a tree of nodes, and this tree has nodes, and every node in the tree is something on the page. So mostly HTML elements, but also text fragments and attributes of these elements, and comments and CData sections, and so everything in the page is a node in this tree. So, and that's basically what I said, it's the most fundamental interface against which we implement our application logic of our web applications. So, and as I said, this consists of nodes, and now this node has an interface. So it has attributes, and it consists of, or it contains some attributes. So now what I just want to point out is the naming of these, because that's really entertaining. So a node has a name, and the attribute that contains the name of the node is called node name. Okay, so and that's basically because the name was already taken at the time when this specification was made. So we couldn't call it name, so we had to call it node name. Then also a node has a value. Although actually not all nodes have values, but some of those nodes has values. Therefore, every node has an attribute for the value that is null eventually for those nodes who happen to don't have a value. So and this value is called node value. Okay. It also has a type, as I said. Nodes have different, or there are different types of nodes for different things, like elements, attributes, CData sections, comments. The document itself is also a node, and so on. So that's the node type. So then, as I said, the document object model is a tree data structure. That is, every node is contained or is the child of another node, which obviously is the parent of this node. So now, since a node has a node name and a node value and a node type, you would perhaps expect to have it a node parent, so that the parent of the node is the node parent. No, however, it is not. It is the parent node. Okay. And then, vice versa, a node has children, of course. That's why other nodes have parents. So that's the other way of the thing. And those children are called, like the parent node, child nodes. That is, the collection of the children is called child nodes. Okay. And now the last thing is, if a node happens to be an element, which not all nodes are, there are other nodes, but some of these nodes are element nodes, and those elements have attributes, or HTML elements have attributes, and attributes are also represented as nodes. So that is, a node has a collection that contains the nodes that represent its attributes. So, and since the children, or the collection of the children is called child nodes, you perhaps could expect the collection of the nodes that represents the attributes to be called attributes nodes. However, it isn't. So, and that's really funny to see in only the definition of 6 properties, 3 different conventions to come up with names. So, and contrast that, please, to something like the C++ STL, where you have a real watertight naming conventions and real well thought out concepts behind the names. So, and, yeah. And I think this is not purely aesthetical also. I mean, you can just say, okay, I'm just an over-aesthetical bitch, and what does it matter? But not the next thing, actually. So I explained, or some more substantial, and I explained that such a document structure of an HTML document is a tree data structure. So this tree data structure has elements like this. This is the tree data, or the document object model of this tiny HTML document. So these are the elements. This is the text, so that's also a node, that is a text node, and so on. So you can easily relate these two to each other. Now the thing is that this is text, right? And if you scan the text and construct this API from the text, then you have to do it one by one. So that is sequentially you read this text, and while you are reading this text, you are building this data structure. Now the problem is that this data structure has all these arrows that point upwards, right? So, and basically these are back references to container elements. The real problem now is that if you have read the document as a whole and constructed the whole data structure, you can create all these arrows, so to speak. However, while you are reading this text and have written it or have read it partially, say until after the div element, it is not really clear which of these arrows already exist and which don't. And the standard actually also doesn't make it clear. So the standard doesn't explain what happens or how does the DOM for a partially read document look like. So, and if you look at web applications as they are deployed nowadays, then you notice that the script that is embedded in the HTML page starts talking to its page before the page is completely loaded. And most of the time it just gets away with it because the browser does something and some of these properties exist. And if you happen not to talk to those properties that don't yet exist, you are fine. So there's a particularly nasty bug or well, actually it isn't a bug, but it is construed to be a bug because people don't realize this problem there. In Internet Explorer, that if you talk to an element in a partially read document, while a table in the page is only partially read, that is, basically if you put script in a table that executes while it is being written, then Internet Explorer replaces the whole document with an error message that says there was an error reading this document or something like this. So something completely unintelligible as you are used it from Microsoft and such. But the real thing is that it just stumbled upon this problem, that you basically can't tell how the DOM looks like if it is not yet complete. So that's a more profound problem with the whole standard than just the aesthetics of names. Although I personally think that those are very important as well. So if you don't take anything else out of this talk, then please just never talk to the page while it is not yet read entirely. Only start running your script in the onload event handler. Okay. So much for this. Just a brief mention of JavaScript, or about a historical note about JavaScript. The thing JavaScript is most readily ridiculed for is the fact that it has this Java in its name. So because semantically, it really has nothing to do with Java at all, actually. It is as different as Java from Java as it could be, yet it is called JavaScript. So, and the thing that is worth remembering, though, is that JavaScript was invented at a time when Java was thought to be a client-side technology. So there was this concept of Java applets that you embed in a page that are written in Java that run as tiny applications inside the page, and particularly can also talk to the page that embeds it and talk to each other. And this orchestrations of different applets written in Java, embedded in an HTML page, talking to each other, was meant to be done in a scripting language. And this scripting language was JavaScript. So, and basically, JavaScript was invented to script Java applications, not as a script version of Java. So, and in that regard, it makes a lot more sense. Of course, this is nowadays completely forgotten because Java somehow didn't catch on as a client-side technology. So it is now a pure server-side technology, actually. Nobody writes applets anymore or Java applets anymore. So, and there's nothing Java left to be scripted on the client side. So instead, we script the DOM now. But still, so the language is not as ridiculously named as it appears. And in fact, it is a quite nice language. So tomorrow I will go into a little bit more detail about these properties of the language. Only so much it has real nice features that are really different from Java. So for instance, it is object-oriented, yes, but it doesn't have classes. Instead, it has prototypes and uses delegation to implement inheritance. And it has a very rich syntax for literals. For instance, you have regular expression literals in the language, but you don't have in Java. So, and the way to execute a regular, or to write down and execute a regular expression in Java is particularly obnoxious. And in JavaScript, you just have literals as in Perl. You also have exceptions and that, of course, and it has been called Lisp with a C syntax. So it is actually really nice. This Lisp with C syntax, particularly because you have this property of closure. So you can dynamically create functions, and these functions can retain the variable bindings of the local scope in which they were created, which is really, really nice. However, still, some quirks remain.